students living alone refrain from ordering food online due to the high delivery costs. It's difficult to find other people who would want to eat at the same place as you. We also see many delivery personnel delivering food from the same restaurant within the same area.
So we came up with FoodStack, a customer-focused platform for placing group orders with anyone who lives nearby. Through this app, you can split delivery costs, avoid any small order fees, and also be notified when your favorite restaurants are having customers nearby.
Let's simulate what would happen if a new user tries our app. When the user opens FoodStack, they click on the Google logo to sign up with their Google account. This then takes them to the welcome screen where they get a brief overview of the app and are prompted to set their delivery address. The map is already set to the user's current location. The user zooms in and chooses their accurate location. Then the user views the home screen with 4 different pathways to order food from and a bar to navigate to other screens at the bottom. They click on the user icon to view their profile and update their display name.
Then the user goes back to the home screen and tries to start a new order, just like in other apps, except this order will be open for others to join. The user is familiar with the heart icon and taps on it to like the restaurant. Since the user is not aware of all the available restaurants, the user filters the fast food restaurants and sorts them according to delivery fee. Then they pick the restaurant they want to order from. On the menu page, the user finds plus buttons for each food item and uses it to add an apple pie to the cart. The user taps on cheeseburger to read more about it and sees that they can add a note to let the restaurant know any personal preferences they have. The user finds the cart icon and taps on it intuitively to view their cart. They decide to wait 10 minutes for others to join and tap on the Confirm Cart button. Here they can see that they'll be reminded to check out at 9:56 a.m. They review their cart, their subtotal, and decide to close the app until checkout.
At 9:56, the user receives a notification to pay for their order. The user opens the app to see that the order is closed and other users have joined their order. The user continues to the checkout page where they can view their payment options of cash on delivery or online payment. They choose to pay online and pick credit or debit card over PayPal. After successfully paying for their order, they view their order summary along with how much money they have saved. The user would now like to track the progress of their order. When the user goes to the home screen after the order is delivered, they are prompted by an alert to rate the restaurant that they have just ordered from.
Now, let's visualize the scenario where the user really likes FoodStack and continues to use it every time they order food. They receive a notification when their favorite restaurant is having customers nearby. They open the app and tap on Join Orders to view the nearby order at Alaman restaurant. They go to the menu and check the time they have to place their order by. However, they want to order the same meal they ordered a few days back, so they go back to the home screen to place their recent order again. Items from the past order that the user has chosen are already added to the cart. The user reviews their order and tries to confirm the cart. However, since a nearby order is already available at that restaurant, the user chooses the option of joining the nearby order. After the order closes, the user receives a payment notification as usual. The user pays for their order by using cash on delivery. Users who join orders instead of creating them can also view their order summary and track progress on their order. When the user does not have any active orders, they can choose to log out from their account to keep their information safe.
ensure the software we developed is of high quality, we followed various software testing practices. Scripted testing was used to design our test cases using equivalence partitioning and the no more than one invalid input heuristic. Unit tests, widget tests, as well as integration tests were used to verify the quality of our app. We use continuous integration to build and test our software whenever new code changes were pushed to GitHub to detect regressions.
We also focused on UI/UX to make sure our app is user-friendly. The key design principle of consistency was achieved with a strategic color theme as well as consistent font styles and widgets. We conducted market research to validate our idea and usability testing with surveys and screen recordings to gather user feedback and improve our UI. We made sure visual feedback is provided for every user action to enhance their experience, and also designed custom illustrations for attractive UI in the app.
We have a few extensions planned for the future. Food Stack could be made social media friendly by allowing users to add friends, invite them to orders, or recommend them meals to try. There could be separate admin apps for restaurant vendors and delivery personnel. Working hours could be implemented for restaurants, and we could also allow users to apply discount codes.
Food Stack is available to both iOS and Android users and was developed using Flutter, Firebase, and Node.js. APIs used include Google Maps API and PayPal's Braintree API. You can access our documentation through the QR code given here. This was presented to you by Team Appetite. Thanks for watching.